This is going to be the makeup video for the measurement lab. This is going to be the makeup video for the measurement lab. Please make sure you have your measurement lab open. This is going to be a quick reminder of how we properly measure using a graduated cylinder or any device. So what you always want to do is find your smallest increment. On the left graduated cylinder, you will notice that our increments are increasing by tens. It's going from 10 milliliters up to 20 milliliters. Then what we need to do is we always want to estimate one place value further to the right. So if we have place values here of tens, ones, and tenths, and we are increasing by increments of tens, we would want to estimate to the ones place. So we would estimate this one too, and I'm going to say that this is roughly 15 milliliters. Now, using the graduated cylinder on the right, you'll notice that we are increasing by increments of the ones place. So when we estimate this one, we will want to estimate one place value further to the right, which would be the tenths. So in this case, even though I think this line is still right on that 15, we have to measure this one to be 15.0 milliliters. So you will always just find your smallest increment and estimate one place value further to the right. Here's another example of how we properly measure. This time, instead of using graduated cylinder, we are going to use a ruler. So here I want to measure the length of this red line. You'll notice that my top ruler is increasing by increments of tenths. It is going from 1 to 1.1 to 1.2 and so on. So here, if I were to measure this one, I always have to go one place value further to the right. So here I think my measurements, or I know my increments are increasing by the tenths place, so I am going to estimate to the hundredths place always. So in this case, I believe that the red line using the top ruler is going to give me a measurement of 1.55 centimeters. Now if all we had was the bottom ruler to measure, it's very hard to be precise in our measurements. In this case, I'm increasing by increments to the ones place, so I'm going to estimate to the tenths place always. So in this case, I might estimate that this line is 1.6 centimeters if all I had was the provided ruler. So with any measuring device that you have, always look at the smallest increment and estimate one place value further to the right. Please make sure you have your measurement lab open, as we are going to begin all of the measurements now. Here is going to be our measurement for activity 1, where we are measuring the length of it and width of an index card. Here we are measuring the length of our index card. Please, using your correct number of significant figures, measure the length of this index card to its correct place value. Record this in your lab notebook now. Here we are going to be recording the width of the index card. Please make sure you note the smallest increment and make sure you measure to the correct number of significant figures. We are now going to begin activity 2 of our measurements lab. Here I'm going to show you an amount of water in 3 different measuring devices. On the left we have a 10 milliliter graduated cylinder. In the middle we have a 100 milliliter graduated cylinder, and on the right we have a 100 milliliter beaker. Now what you will be doing is looking at the smallest increment. I want you to please estimate each of these measurements to the correct number of significant figures. I will pause on each one for a few seconds so you have a chance to take the proper reading. Please record those values in your measurement lab now. We are now going to begin activity 3 of the measurements lab. During this portion of the lab, we are going to be measuring the mass of 30 beans. Here you can see I have the 30 beans placed onto the scale for you already, or onto the triple beam balance I should say. And here you can see the mass that we have these recorded to. Please record this mass into your measurement lab. We are now going to begin activity 4 of our measurement lab, measuring and calculating the density of a regularly sized object. For this activity, we will be finding the volume of a cube. Please record the length of this cube and use your knowledge of finding volume of a cube to solve for the volume of this. For activity 4, we also need to know the mass of the cube in order to find its density. Please record this mass of the cube into your measurement lab. We are now going to begin activity 5 in your lab, finding the volume and density of an irregularly sized object. We are now beginning activity 5, finding the mass and volume and density of an irregularly sized object. So first we are going to be finding the mass of the battery. Please record this mass into your measurement lab. Now we are going to be finding the volume of an irregularly shaped object. One thing students will oftentimes try to do to find the volume of a battery is they think that they can just measure it with a ruler again. The downside to this is battery is irregularly shaped. It is not a perfect cylinder. So how can we find the volume of this? Well, what we can do is use a method called water displacement. So what I would like you to do is record the initial volume in this graduated cylinder. After you have recorded the initial volume in the graduated cylinder, I'm going to add the battery in, and whatever water level changes, that is going to be the volume of our battery. Please record this final volume in your measurement lab. We are now going to begin activity 6 of the measurement lab. In activity 6, we are comparing the precision of two different measuring devices. So here I've added approximately 83 milliliters to a 100 milliliter graduated cylinder. Please make sure that you're recording this with the correct number of sig figs. Now I'm going to take this water and pour it into our 100 milliliter graduated cylinder, and I would like you to again now measure the volume of the water now that we are using a different measuring device and see if your answer changes. Please record this number in your measurement lab.